All right, we're looking at three big functions we're going to spend most of the rest of the year dealing with, which are position, velocity, and acceleration, and how they all affect each other. We'll do all three of them at the same time. So we're looking at position, velocity, and acceleration. Most of the time they give you a position function. It will be in the form x of t or s of t. When you see velocity, it's usually v of t. And when you see acceleration, it's usually a of t. Now, velocity is the derivative of the position function. Velocity is the derivative of the position function. Acceleration is the second derivative of the position function or the derivative of the velocity function. So that's how the three are related. Okay, now another thing we're going to bring up later on today is speed. And speed can be confusing because speed is what you guys are used to when you're driving a car. Okay? Because what is that thing on the car that tells you how fast you're going? It's a speedometer. Okay? So that speedometer obviously tells you the speed you're going. Okay? So that can be confusing with what velocity is. Speed is always positive. Velocity is not always positive. Okay? Velocity tells me two different things. Okay? It tells me how fast I'm moving and the direction I'm moving. Okay? If velocity is positive, that means I'm moving forward. I could be moving to the right or moving up. When velocity is positive, it usually means one of those three things, depending on the context of your problem. I'm moving forward, I'm moving to the right, or I'm moving up. When I'm talking about velocity being positive. If velocity is negative, what three ways am I going to move? Down, left, or back. So when velocity is positive, I'm moving forward, right, or up. When velocity is negative, I'm moving backwards, left, or down. Questions on that? Okay. All right. Now we're going to use the car scenario to help us kind of get a grasp on position, velocity, and acceleration. All right. So if I'm driving forward on a car, what is my velocity? What can I say about my velocity? It's positive. Okay. So if my velocity is positive, that means I'm moving forward, which means my position is changing how? It is increasing. Okay, so that's the first thing I want you to write down. If velocity is positive, that means my position is, what do we say? Increasing. So a positive velocity means my position is increasing. And that goes to say that a negative velocity means my position is decreasing. Okay, so that's the relationship between velocity and position. Positive velocity, I'm increasing my position. Negative velocity, I'm decreasing my position. Okay, and something I need you to notice there is when we're talking about velocity right now, what are we saying about velocity? Negative or positive? Okay, but when we're talking about position, what are we talking about? Increasing or decreasing. Okay, that's the way you always need to talk about it when you have a derivative and you have the function above it. Okay, you always talk about the derivative being positive or negative. You always talk about the function being increasing or decreasing. Okay, so the bottom function is always positive or negative. The top function is always increasing and decreasing. Okay, you are correct. Now let's talk about the relationship between velocity and acceleration. If I'm in a car, what can I think about if I'm thinking about acceleration? There's two things I can think about. The gas pedal and the brake pedal. If I'm pressing on the gas pedal, what's my acceleration? It's positive. Okay. If I'm pressing on the brake, my acceleration is negative. Okay. So go back to acceleration. If I'm pressing on the gas pedal, which means acceleration is positive, what does that tell me about my velocity? Yeah, if I'm pressing on that gas pedal, my velocity is increasing. So a positive acceleration results in a increasing velocity. Positive acceleration results in an increase in velocity. So make sure you have that written down. Positive acceleration means velocity is increasing. Positive acceleration means velocity is increasing. Okay, and a negative acceleration means that my velocity is decreasing. Okay, so I come back up here. On velocity, we're talking about increasing and decreasing. On acceleration, we're talking about positive versus negative. So on velocity, sometimes you're going to think about it as positive or negative. Sometimes you're going to think about it as increasing or decreasing. Okay? On acceleration, most of the time it's positive or negative. And on position, most of the time it's increasing and decreasing. Okay? But what we need to understand so far is, if I'm going to determine if a function is increasing or decreasing, where is it I need to look?
No, the X. I don't know.
You're way off.
Okay.
What?
If I'm interested to see if position is increasing or decreasing, or velocity is increasing or decreasing, or acceleration is increasing or decreasing, if I want to determine if a function is increasing or decreasing, where do I need to look?
Sign of the derivative.
The sign of the derivative. That's what we need. That's the first thing we need to grasp today. Did you say that as well?
No, she said. I was like, just say it.
That's the first thing we need to understand. If I'm trying to determine if something is increasing or decreasing, where do I need to look?
Sign.
I need to look at its derivative and determine if it's positive or negative. If the derivative is positive, that means you are increasing. If the derivative is negative, that means you are decreasing. That's the first major concept right there that we need to get our heads around. If I'm determining if something is increasing or decreasing, I look at the derivative. Derivative is positive, I'm increasing. Derivative is negative, I'm decreasing. Okay? Everybody with me on that? All right, now let's bring in speed at this point. What did we say speed was always? Speed is always positive. Okay? So let's think about this. Alright, let's say I'm going down the road and I'm pressing on the gas pedal, which means my velocity is increasing and my acceleration is positive. So my acceleration is positive and my velocity is increasing. What's happening to my speed? It is also increasing. My speed is also increasing. So we said acceleration was positive and velocity was increasing. And if velocity, no, hold on, let me make sure I'm saying that right. Okay, we need to go one more step. So acceleration is positive, which means velocity is increasing. Okay, and if velocity is increasing, and I'm going forward, what does that tell me about my position?
It's increasing.
It's increasing. So if my position is increasing, what does that tell me about my velocity?
Positive.
It's positive. Very good. So right now I know my speed is increasing, and my acceleration is positive, and my velocity is positive. Okay? Let's talk about another scenario. Let's say I'm going down the road. Okay? And let's say this time I'm pressing on my brake, which means acceleration is
Decreasing.
negative,
Yeah.
which means velocity is decreasing, but I'm still going forward, and if I'm still going forward, that means position is still increasing, which means velocity is, it's still positive, because I'm still going forward. So this time acceleration is
Decreasing. Or
negative, velocity is
Decreasing.
positive, okay? So the two are different. What's my speed doing if I'm pressing on the brake? It's decreasing, okay? So there is a relationship between velocity and acceleration that determines whether or not my speed is increasing or decreasing, okay? And from that little thing we did just there, can you tell how we can tell if speed is increasing or decreasing? In the first one, we said speed was increasing. What was going on to my velocity and acceleration when I was increasing? They were both positive. On the second example, we said acceleration was negative, but velocity was still positive. So what's going on between velocity and acceleration there? They're different. That's how you tell if speed is increasing or decreasing. If velocity and acceleration are the same sign, that means speed is increasing. Write that down. If velocity and acceleration are the same sign, that means speed is increasing. Okay? If velocity and acceleration are different signs, what does that tell me about speed? It's decreasing. There's one more thing we need to know about speed. It is also defined as the absolute value of velocity. And what speed is defined as. It's the absolute value of velocity. And why is there absolute value on it? Because it's always positive. That's why speed is the absolute value of velocity.
I was thinking that from when you said that it was positive.
Any questions on what we've covered so far before we get into the problem? Here are the main things I want you to be able to know right now. I've got position. The derivative of position is velocity. The derivative of velocity is acceleration. Okay? The next thing I want you to be able to tell is if I want to determine if something is increasing or decreasing, where do I have to look?
The sign of the derivative.
The sign of the derivative. Okay? If the sign of the derivative is positive, that means the function is increasing. If the sign of the derivative is negative, that means the function is decreasing. And the last thing we want is speed. We want to know the speed is the absolute value of velocity. To determine if speed is increasing, I have to look at velocity and acceleration. And what is going on if it's increasing? They're the same sign. And what's going on if it's decreasing? They're different signs. All right, let's look at a problem. Page 114, we're looking at example 10. What we have here is we have a diver, and his diving board is 32 feet above the ground, or I guess it's a platform. It's 32 feet above the ground, and he jumps off the platform and then heads down to the water of the swimming pool. It's saying the position of the diver is given by the position function S of t equals negative 16t squared plus 16t plus 32. So they have given me the position function. Okay, and they're asking me a couple questions about what's going on here, and I'm going to add some more questions to it. Okay? First thing it wants to know is, when will this diver hit the water? So when will this diver hit the water? Okay, when they ask questions like this, the first thing you have to understand is which function is it they want me to deal with. Do they want me to deal with position? Do they want me to deal with velocity? Do they want me to deal with acceleration? Okay, what do you guys think on that first part?
this is going to be feed. We'll use the position
Okay, we're going to use, he's not very confident in his answer, but he's correct. We need to use the position function. Can somebody explain to us why we want to use the position function? We need his time when the position is 0. Very good. Because when I hit the water is ground level, and if I started at 32 feet, ground level is going to be 0. So I need to use the position function, and I'm interested in when the position function equals 0. So I want to set my position function equal to 0. And I want to solve this. What's something that'd be really nice, really helpful to do?
Divide by 16.
Say it again.
Divide by 16.
I wouldn't divide just by 16. I would divide by
Negative 16.
negative 16 is what I would divide by. So that gives me t squared minus t minus 2. Now what do I want to do with what's left? Factor. How's that factor?
T minus 2, T plus
Okay, so that gives me t values of
2 and negative
2 and negative 1. Now what does t represent again?
Time.
Time. So which answer do I want?
1. Positive
2. Because I can't have negative time. So that means at 2 seconds, what's going on with this diver?
He's hitting the wall.
He's hitting the water. So he jumps, 2 seconds later, he's hitting the water. That's what we figured out there. Okay? All right. Part B. What is the diver's velocity at impact? I want the diver's velocity at impact. If I want velocity, where do I need to go? Derivative of position, which gives me the velocity function. Okay? So what they're really going to want, and I'm not going to be real picky as we get started. Once we get to where we're reviewing, I'm going to start getting pickier. What they're going to want to see is they're going to want you to show that s prime of t equals v of t. They're going to want you to connect that the derivative of a position is velocity. So it's always good to show them that you know what's going on. So I need to take the derivative of this, and that gives me negative 32t and plus 16. So my velocity function is negative 32t plus 16. Now what is it they want me to find?
Velocity at impact.
Velocity at impact, which is at 2 seconds. So what do I do to find velocity at impact?
Plug 2 into 2.
I plug 2 in. So negative 32 times 2 plus 16, negative 64 plus 16, and that gives me negative 48. Negative 48 what?
Feet per second.
Feet per second. So feet per second. All right, let's talk about what that means. If my velocity is negative, what does that tell me about my position?
Going down, left, or back.
All right, and in this case, what am I doing? I'm going down. Does that make sense? If my velocity is negative, I have to be going down. We've shown that the velocity is negative. Okay? Now, let's talk about acceleration. Let's find his acceleration at impact. So what do I need to do to find acceleration at impact?
Find derivative, or the second derivative.
I need the second derivative. So we're going to show that v prime of t equals acceleration, and what is the derivative of velocity in this case?
30. Just
And then negative 32? Is there a variable with it?
No.
So what does that tell me about acceleration?
it's negative.
If there's not a variable with a number, what does that tell me about acceleration?
The
It's constant. So that means acceleration is always Negative 32. Now, we need to put a unit on this. What's my units on acceleration?
Feet per second squared.
Feet per second squared. You can also hear it as feet per second per second. Either way. But my acceleration is negative 32 feet per second squared. Since it's negative 32 feet per second squared, what does that tell me about my velocity?
It's also decreasing.
Velocity is decreasing. Okay? Because acceleration is negative, that tells me my velocity is decreasing. But there's one more thing I want to talk about.
Speed is increasing.
I want to talk about speed. What do I have to look at to determine speed?
The sign of velocity.
Sine of velocity and the sine of acceleration. And what are they on this one?
Both
They're both negative, and what does that tell me about my speed?
increasing.
My speed is increasing. Does it make sense that his speed is increasing?
Yes.
Yes, because if I jump off a building or whatever, and as I go down, my speed is going to be increasing. Okay? My speed is going to be increasing. Okay, now, here's my next question. We figured out at impact, my velocity was decreasing. Okay? Is there a point in this where my velocity is increasing?
The first, as you jump up off that one. Does this go up first?
Okay, you didn't listen to my question.
Like at the position.
Is there a point somewhere in this dive where my velocity is increasing? I'm hearing yes. Anybody disagree with that?
Right, because it goes up. Or is that-
How do I determine if velocity is increasing or
If
decreasing?
he goes up, right, or forward. Well, it does go forward.
Right, if velocity is.
Or if acceleration is positive.
If acceleration is positive, that tells me velocity is increasing. Is my acceleration ever positive? No, so that means my velocity is always decreasing. Okay, now here's the next question. Listening closely, is my velocity ever positive?
Yes.
Why?
Ooh, at -1, our position would be like relative, I think.
We can do negative time.
Oh, yeah, not position. Sorry.
Look at the diagram.
Well, like the first half second or so.
Okay, why?
Because
Why
it
am I?
goes up first.
There's what we're looking for. And because I'm going up, what's my position doing?
Increasing.
If my position is increasing, what does that tell me about velocity? It's positive. Okay? That's where you have to be careful and you have to listen for positive and you have to listen for the increasing and decreasing part. Okay? And how it all relates. Okay? That's what's really, really, I consider fun about these type of problems is understanding what they're asking and where do I get the answer